This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week in Exploration, we discuss the fascinating world of science and its impact on society. And today, leading off, once again, we're going to summarize some of the top stories in science and politics this week. The lead story today concerns, well, your cell phone. Is your cell phone dangerous? I mean, after all, it is a source of electromagnetic radiation, and a new report and a new study conducted on mice shows that, well, there may be a causation between radiation from your cell phone and problems with diseases in your body. But we'll go through the pros and cons of this new study. Second of all, antibiotics are in the news. The inevitable has finally happened. We knew that sooner or later a superbug that is resistant to all known forms of antibiotics would arrive on our shores. Well, it finally happened. A version of the E. coli bacteria was in fact picked up, and it's causing shivers to go down the spines of many doctors, many epidemiologists, and public health officials, realizing that we could be at the end of our rope in terms of the antibiotic revolution. And then, speaking about diseases, the Zika virus once again is hitting the news. And the inevitable has finally happened. It has now arrived in the United States. And in fact, there's some physicians that wrote a letter stating that perhaps the Brazilian Olympics should be moved as a consequence. And we also know that the Zika virus can be spread not just by mosquitoes, but also by sexual contact as well. In fact, right now, scientists are trying to develop a genetically modified mosquito to combat the spread of this mosquito and the Zika virus. However, we should also point out that there's another danger there. If you create a new species of mosquitoes to combat the old species of mosquitoes, just remember that you cannot recall a life form. There are unintended consequences when you do this. And also news from outer space. SpaceX, the company pioneered by the billionaire Elon Musk, who also founded PayPal and Tesla Motors, scored 3 successful launches in the last 2 months of a reusable booster rocket. And many people are saying that this could usher in a new phase in the economics of space travel. We should also point out that Elon Musk made headlines a few months ago when he said that, well, maybe we should nuke Mars, drop hydrogen bombs on the polar ice cap to begin the process of terraforming Mars. Well, a lot of eyebrows were raised as a consequence of that statement, and now he's further elaborated that he did not mean dropping hydrogen bombs directly on the ice caps of Mars. So we'll talk about that in a minute. And also, of course, election fever is rising to a fever pitch, especially over the number one issue, which is the economy. And some people are saying, well, why aren't we recovering like we used to in all the previous cycles of recession and booms and busts? Some people think it's technology. And some people think that, well, perhaps the robots are getting too smart. So we'll bring on our special guest today, Ray Kurzweil, author of the book, The Singularity is Near, talking about if and when robots will begin to approach human reasoning capabilities. Okay, well, let's just jump right into some of the top stories of the past week. The lead story today concerns cell phones. Everyone has them. I mean, it's a necessity. Can you imagine going outside the door without your cell phone? The first thing you do is rush back to your house, and if you lost it, heaven forbid the chaos that's created with a lost cell phone. Well, that's why this new study, the latest in a series of studies, in fact, has raised a certain number of eyebrows. The studies were done, first of all, on mice. They shot large quantities of cell phone radiation, much larger than normally found, for hours at a time. And yes, they did pick up some problems in the mice. However, we should also point out several basic facts. First of all, there are 2 kinds of radiation that we have to very clearly demarcate. The first is ionizing radiation, radiation that is so intense that it'll actually rip apart atoms. And these ions, these stripped-down atoms, can go on and create chaos in the molecular machinery of the cell, causing cancer and any number of other kinds of diseases and mutations. X-rays are perhaps the most famous of the ionizing forms of radiation. But then we also have non-ionizing forms of radiation. Radiation that's so weak in energy that it is incapable of ripping apart the atom. For example, television, radio, microwaves. These are non-ionizing forms of radiation that will not rip apart the atom. Now, we know from the Hiroshima bomb, and also studies done decades ago on patients who got extraordinarily large amounts of X-rays in those days, that yes, we can correlate the amount of X-rays to the number of cancers and other diseases that radiation can cause. However, cell phone radiation is in the microwave range. That is, it's non-ionizing. This has prompted many scientists to say, humbug. Cell phone radiation in the microwave range is simply too weak to create ions, too weak to create the disturbances in our cells which eventually give rise to cancer. Therefore, all these studies must somehow be suspect. Well, several years ago in Stockholm, Sweden, at the Karolinska Institute, a very prestigious scientific institute of Sweden, they did a study on high-voltage power lines. That is, not just cell phone radiation, but gigantic towers emitting huge amounts of radiation, again, non-ionizing. And then they calculated the incidences of cancerous lesions and other problems as a function of distance from the wires. And sure enough, they found that there was a correlation, a very weak correlation. That is, the closer you were to a high-voltage power line, there was a mathematically measurable increase in the problems that would arise as a consequence. Now, the Karolinska study was the first to show, therefore, there is a link between non-ionizing radiation and cancers and other kinds of lesions and problems. But you have to realize that, well, we're not talking about high-voltage lines. We're talking about cell phones. We're talking about objects which have a tiny fraction of the energy that's emitted by these high-voltage lines. So what's the conclusion? The conclusion is there a cause for some concern? And the answer is, well, yes. We're on the very borderline of what we can measure. But is there a reason for panic? And the answer is absolutely no. There's no reason for panic, but, of course, there's always room for new studies and more information concerning the link. Now, we should also point out, of course, there are lots of urban legends spreading about this. One urban legend which was debunked was the fact that one person held a cell phone right to his ear and eventually came down with a brain tumor in the shape of a cell phone. Well, that makes for a great story, but that has been unsubstantiated. Now, if you are really serious about getting to the bottom of this, why bother to speculate? Go to a scientific supply company, there are many listed on the internet, and download Gauss meter or magnetic field meter or magnetometer. A Gauss meter is a very simple device that measures the AC magnetic field in the air. And you can go around your room, which is what I did, with a milligauss meter and actually measure the amount of radiation in your room. I was rather surprised to find that the largest amount of radiation in my living room was not my cell phone at all. It was the cable box and the hairdryer. Yes, it turns out that your hairdryer can hit you with about 100 milliwatts of electromagnetic energy along with your cable box, but a cell phone hardly registers at all. So, and also electric blankets, you have to worry about them because, of course, you are immersed in electromagnetic field for 8 hours of every night. So, once again, should you panic? And the answer is no. Should you throw away your cell phone? No. But you might be a little prudent. You might want to cut back a little bit on the amount of time you spend on your cell phone. and keep up with the scientific literature. Every now and then a new report comes out, again finding very minimal correlation between the two, but you cannot dismiss these reports. Also, on the scientific front, antibiotics are in the news. You know, back in the year 1900, the average lifespan of an American in this country was, believe it or not, 49 years of age. And now people living today can expect to live perhaps into their 80s. So what happened? Well, what happened was basically three things happened. The biggest contribution to our life expectancy was sanitation. You realize that back in the bad old days, like the Middle Ages, people would throw garbage right out of their window onto the street. The streets became a sewer of all the rotting food left over from dinners long past. And if you read Gothic novels, and novels going back a few centuries, then you realize, yes, people had to avoid areas which stunk so much because there was no sewer system, no clean water. Now, of course, we have good sanitation, relatively speaking, and that has added perhaps 15 or so years to our life expectancy. Then we have vaccines, and then we have antibiotics, which again add decades to our life expectancy. And so those three things are the major reasons why we live much longer than before. Well, now we have the end of the age of antibiotics. And all of a sudden, this bestiary of diseases that we long ago forgot all about may come back to haunt us. It was inevitable. It's Mother Nature. It's evolution. Bacteria, well, they're not stupid because, of course, they don't think at all, but they adapt. And they can adapt much better than our finest biotech or company. And what happens is they mutate generation by generation, sharing genes between different species of bacteria, until they come up with one gene that makes them resistant to all known forms of bacteria. This is a cause for major concern. And the bad news is the germ that they discovered that has an immunity to all known forms of antibiotics was E. coli. E. coli is very common. You find it in your gut. E. coli is practically everywhere. And mutated forms of E. coli will cause food poisoning. And so this is something that we have to take very seriously. It's a problem because many drug companies do not want to spend the billions and billions of dollars necessary to create and market new forms of antibiotics when there's little demand for it. However, this could be a game changer. So watch carefully as scientists try to combat the superbug, that is, a germ that is basically invulnerable to all known forms of antibiotics. And we could go back to the bad old days. And speaking about viruses and germs and bacteria, the Zika virus continues to be in the news. Just this week, for the first time in the United States, it turns out that a carrier of the Zika virus was discovered. She's from another country, and some doctors are saying that we should perhaps think about moving the Olympics away from Rio de Janeiro. Some people are saying that that could be a focal point for spreading the Zika virus around the world. Now, some people say, well, my country doesn't have that many mosquitoes, but you don't have to have mosquitoes to spread the virus. We now know that in the United States, it's mainly spread by sexual contact. That's right, sexual contact. So it means that it could very rapidly spread in the U.S. population as well. So this is something that we have to really seriously consider. Now, one of the things being tried out now is to create a new species of mosquitoes which are sterile. You release them, they're ordinary mosquitoes except they're sterile, and they mate with other mosquitoes, but they don't create progeny. And some scientists believe that perhaps one day we might be able to completely eradicate that version, that species of the mosquito. However, we have to look at this very carefully. First of all, you cannot recall a life form. Once a bug gets out of the laboratory, it proliferates. In fact, that's what bugs do. And mosquitoes will proliferate even if they are genetically modified. But let's say there's one mosquito that is incorrectly genetically modified, and they become a super mosquito. So you have to be very careful, because once the cat is out of the bag, once you release these genetically modified life forms into the environment, you cannot recall it. You cannot say, oops, there it goes. And as an example of this, think of the so-called killer bees. Africanized bees were actually introduced into Latin America in the 1950s. They escaped into the wild, and now they've taken over most of Latin America, most of Mexico, and now they're entering into the United States. Killer bees, compliments of the fact that humans cannot recall a life form. Once it's out of the bag, it is out of the bag. And also, SpaceX continues to make news. One of the reasons why we don't have tourists going into outer space is because of cost. It costs $10,000 to put a pound of anything into orbit. Just think about that. Take a glass of water and send it into outer space in the space shuttle. Realize that per pound is $10,000. That's what it costs just to go into near Earth orbit. And to go to the moon would cost perhaps on the order of $100,000 a pound. To go to Mars, it may require $1 million a pound, your weight in diamonds. And so on the Earth, we have to do something about reducing the cost. One thing you can do is to reuse the booster rocket. Just remember that most of the fuel of a rocket goes into launching itself into space. You may say to yourself, that's a waste, but that's the way it is. The fuel of the rocket, most of it goes to lifting the fuel into outer space, and that's why we jettison the booster rocket hull. But isn't that a waste? Why not retrieve the booster rocket by putting mini jets on the booster rocket so it can gently land back on the planet Earth? And that's what SpaceX did 3 times in 2 months. This has really shocked the people in the field who were getting a little bit pessimistic after so many missed trials. But SpaceX, you got to hand it to them, 3 times in the last 2 months. SpaceX is on a roll, and if this becomes the norm, it could drastically reduce the cost of space travel. For example, if you right now wanted to sign up to go into outer space on Spaceship Two, it would cost about $200,000. For you to go up on the space station, the International Space Station, not just go up and down, but go around the planet Earth many times, it costs on the order of $20 million. In fact, right on exploration, we had a Microsoft billionaire, the man who actually went into outer space on the International Space Station, even though he's a private citizen. I told him that the media speculates that it cost him $20 million for that trip. Was that true? Well, he was rather coy about this. He signed a contract not to reveal the exact amount of money he paid to go into outer space. But he said, quote, that's in the ballpark. So, that's in the ballpark, about $20 million if you want to go into outer space. And also, the creator of SpaceX, the creator of Tesla Motors, and the co-creator of PayPal is Elon Musk. He continues to make headlines. A few months ago, he made headlines by saying that as far as Mars is concerned, we should nuke Mars. First of all, he actually has plans to modify the Falcon rocket to actually go to the red planet. Just think of that, a private citizen with enough resources to send a rocket all the way to the planet Mars. Will it deliver a hydrogen bomb on the ice caps to begin the process of warming up the red planet? He qualified his statements. He said no. By nuking Mars, he did not mean dropping a hydrogen bomb directly on the polar ice caps to begin the process of melting the ice caps. That would, of course, be a shortcut toward terraforming Mars. But again, there are unintended consequences. We don't know what's going to happen to the stability of the ice caps of Mars if you drop a hydrogen bomb there. We don't know what happens to the water that is going to be created by the detonation of a hydrogen warhead on the polar ice caps. And the polar ice caps themselves are made out of 2 substances. First of all, you have ordinary water ice, But second, you have dry ice or solidified carbon dioxide. So we have two substances that make up the composition of Mars, making it even more difficult to project what might happen if you drop a hydrogen bomb on the red planet. Well, he clarified his comments. Elon Musk says, no, he didn't really mean dropping a hydrogen bomb directly on the surface. He meant creating some kind of fusion in the high atmosphere of Mars, that is, in outer space, essentially. And that may create enough warmth to begin the process of terraforming Mars. Well, whichever form we eventually decide to use, it's not going to take an overnight mission to terraform Mars. We're talking about a mission that may take centuries. For example, 2030 is the very earliest that we could envision sending a manned probe to the planet Mars. More than likely, it'll take place late in that decade or maybe before 2050. And that's just the first mission to Mars. Then to begin colonization, that is setting up a permanent Mars base, that'll take a few more decades. And so by the end of this century, we're not going to have a gigantic Mars base with all the comforts of home. No, by the end of the century, probably we'll have outposts, small little outposts of astronauts. If you saw the movie The Martian, for example, starring Matt Damon, that would be what Mars exploration might look like late in this century. Because we are, of course, talking about the fact that it takes 2 years to get to Mars, and we only have a launch window every 2 years. So in other words, we might be able to send a mission to Mars every 4 years. And so it's a long-haul mission. And just remember that there's the famous Mars jinx. And that is over 50%, closer to about 75%, of missions to Mars fail. I repeat, this is the Mars jinx, the fact that over half the mission to Mars fail. Now, of course, the United States has had some good luck, a streak of good luck recently. But if you take a look at the track record of Russia, the track record of the European Union, you realize that, hey, Mars in some sense is a graveyard for hasty missions that simply did not have all the backup systems to put a mission on the red planet. And also, as everybody knows, we're in the thick of election season. The fever is beginning to really reach a crescendo with Donald Trump and Hillary Clinton aiming fire at each other. And the number one issue is jobs. That's the number one issue dominating all the polls. And one of the reasons why we see a change in the job market is because of technology. For example, usually under capitalism, after every cycle of boom and bust, we have a new generation of jobs coming in, and it means that the unemployment rate begins to fall after the crash. Well, we don't see that right now. We see record levels of stubborn unemployment. And some people think that perhaps the reason is corporations discovered that they really don't need that many employees because of computers, because of software, because of technology. And as a consequence, when the cycle should have started again, when companies are roaring up and putting out new products, they should be hiring more workers. They got used to the fact that they really don't need that many employees. For example, middleman jobs. Middleman jobs are directly affected by computers because computers are adding machines which can keep track of inventory, do bean counting, and do the jobs that brokers used to do in the past. For example, if you're a stockbroker, you know that you can buy stocks on the computer now. You don't necessarily have to go to a human being unless you want specialized advice, which is what a lot of stockbrokers are offering now. And the same thing for example, the airline industry. When you call for an airline ticket in the old days, you had to talk to a human. Now most people go on the web and they just book their airplane tickets right there. Or many times in the past, a secretary would type up manuscripts and type up correspondences and keep track of things and file papers. And now, a lot of that can be done by computers. So some people think that one of the reasons why the hiring of workers after the crash has been rather sluggish is because corporations began to realize, hey, we can get by. we can get by with not that many workers because of technology. Now, the solution to that problem, one of many solutions, is education. To educate the workforce so they can handle jobs which incorporate computers in the day-to-day work. Workers have to be computer literate. They have to take advantage of computers, know how to service them, know how to use them in the course of their work. Rather than fighting against computers, they should learn the skills necessary to navigate in the cyber age. So education is going to be important. Also, job creation is going to be important, encouraging entrepreneurs to create those very corporations which will then begin the process of hiring workers. And so it's a rather complex problem, but yes, technology has something to do with the fact that the workplace is changing. In fact, some scientists believe that one day robots will become so intelligent that they will be, in some sense, a rival for dominance of the planet Earth. We have evolution, for example, that says that one species replaces another species because it's survival of the fittest. Well, what happens if our progeny become a new species and they are fitter than us? I mean, after all, we can make robots that are stronger than us, faster than us, can work in outer space or at the bottom of the ocean. Robots can do all sorts of things that we cannot because we're made out of wetware, not the hardware of a robot. And so then the question is there a point at which we become yet another extinct species on the planet Earth? Well, who knows for sure, because we're talking about something that is still decades into the future. So we're going to bring on Ray Kurzweil. Ray Kurzweil is famous for writing the book, The Singularity is Near, talking about the singularity, the point at which our creations, that is the robots, begin to rival and then surpass human intelligence. And if robots can create progeny, perhaps they can create second-generation robots smarter than the first generation. And then they could create third, fourth-generation robots smarter than the previous generation. And, of course, they can do all of this much faster than we can. In fact, some people say, therefore, that we are creating our evolutionary successors. Other people say, come on, give me a break. The state of robotics is so primitive that it may take, well, decades, maybe centuries, before we can begin to approach human intelligence, because it turns out that human intelligence is a lot more difficult than we previously thought. Well, once again, our special guest today is Ray Kurzweil, and we'll be talking about the singularity, and we'll be talking about, well, is it really credible that one day we will be the creators of our evolutionary successors? That just like one species overtakes another species in this continual process called survival of the fittest, what happens if we humans are not the fittest? Well, think about that. We'll talk about that in the second half of Exploration. Well, I'm afraid that's it for the first part of Exploration. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College of New York, and you've been listening to the first part of Exploration. Stay tuned for the second part of Exploration when we talk about the future of robots. Are the robots going to take over one day? Our special guest today is Ray Kurzweil, author of the book, The Singularity is Near. How close are we to the time when they'll be as smart as us? Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and you're listening to Exploration. In the first half of Exploration, we begin a summary of some of the top stories of the past week in science, including the cell phone controversy. Cell phones, are they really dangerous? Antibiotics, a new strain of superbugs has now been detected in the United States, which seem to be invulnerable to all forms of antibiotics. And the Zika virus, now in the United States. What does it mean? Especially given the fact that it can be spread not just by mosquitoes, but by sexual contact. And then SpaceX. SpaceX has pioneered the reusable rocket. Will that change the economics of space travel? And then we're going to shift gears because we're going to talk about the job market and artificial intelligence. Will one day the robots take over from the humans? And in the second half of Exploration, we're going to bring on inventor Ray Kurzweil, author of a number of bestsellers, including The Age of Spiritual Machines and The Singularity is Near. And his thesis is a controversial one. It's a minority opinion, but it's an opinion that has to be heard. And his claim is that very soon, perhaps by 2020, perhaps very soon, machines will begin to approach human intelligence and perhaps even exceed human intelligence. And even worse than this for humans, robots will be able to create copies of themselves that are even more intelligent than they are. And so they'll be able to bootstrap themselves to become arbitrarily intelligent, in which case they may begin to leave the Earth and begin to colonize the galaxy. That is called the singularity, the point at which we have runaway machines creating machines of even higher intelligence, and the whole process just keeps on going until they, take over the universe. Sounds like science fiction? Well, yeah, but it's a position that can't be ruled out. So once again, our special guest in the second half of Exploration is inventor Ray Kurzweil, and we are talking about, what happens when the computer revolution goes amok? Mr. Kurzweil, the first question for you is, how did you first get interested in robots and artificial intelligence?
I've actually had in mind being an inventor since I was at the age of 5. And age of 12, I discovered computers. I built some primitive computers myself and got access to one as part of a summer job. And quickly became fascinated with the ability to kind of model the world, albeit primitively at that time, in the computer and create virtual realities, and also model our thinking processes. Quickly became interested actually in pattern recognition, which is my view is the fundamental basis of human intelligence rather than logical, sequential, analytical thinking. And a project I did in high school was to build pattern recognition models of melodies, and I would feed in the melodies of Mozart or Chopin, and it would build a pattern recognition model and then write original melodies in the same style from that model, which were recognizable. It sounded like second-rate compositions from a second-rate student of Chopin and Mozart. And that started really a lifelong fascination in pattern recognition, which is really my primary technical field.
Okay, and let's talk about your book, The Age of Spiritual Machines. First of all, what is a spiritual machine? Is that a contradiction in terms?
The primary concept of spirituality is really consciousness. If we consider a being or an entity to be conscious, then we consider it to have spiritual value. And if you look at all the different religious traditions, what they really mean by a soul and by spiritual reality is consciousness, an entity that really has subjective experience and can feel pain and joy, as opposed to just the conventional concept of a machine, which is operating by some kind of automatic process. And we don't worry much today about causing pain and suffering to our computer programs. But our computer software is still millions of times simpler than the human brain. We do find, if we look at the human brain, that we actually can model it with great precision neurons and even substantial clusters of neurons. We can talk more about that. And we will have machines, which is to say non-biological entities, that do have the complexity and richness and depth of the human brain, indeed modeled on the principles of operation of the human brain within a few decades. And when these entities claim to be conscious, to be joyful, fearful, angry, and so on, unlike, let's say, the computer characters in video games today, those entities a few decades from now will be as convincing as humans. They'll have all the subtle emotional cues that we associate with somebody really having those subjective experiences. So are they conscious? Some philosophers will say no, they're not squirting human neurotransmitters. You can't be conscious if you're not biological. But there won't be any clear distinction. We won't be able to separate them from any kind of objective observation. And my prediction, and this is really not a philosophical statement, but a psychological and political prediction, is that the bulk of humans, unenhanced humans, will consider these non-biological entities to be conscious. In any event, they'll be very intelligent. They'll be able to convince us that they're conscious, and they'll get angry at us if we don't believe them. And it'll be an actual political and legal issue as well. In my view, the real issue of consciousness is not something we can resolve scientifically, because science involves third-party objective observation. Consciousness is inherently first-party subjective experience, and there is a gap there. Some people go on to say, well, since it's not scientific, it's not an important question. I would turn that around and say it's really a very fundamental question. It shows that there is a need for philosophy outside of science. But these will become real compelling questions as opposed to just abstract philosophical debate in this 21st century.
Okay, and let's talk about the past first as a guide to the future. Back in the 1950s and 60s, there were dazzling breakthroughs in artificial intelligence theory. We had the first machines, for example, that could play chess and checkers. Not very well, but they could at least play the game. They could solve simple algebra theorems. They could even play doctor to a degree and do simple diagnoses. And there were all these fantastic predictions that just within a few years, humans will be put in a zoo. We'll all be zoo animals, and our creations will throw peanuts at us and make us dance behind bars, because look at how fast computers are learning. And then there was the movie 2001, and, well, the year 2001 came and went, and we still do not have the robot Hal, the murderous robot in Arthur C. Clarke's famous movie that could pilot a spaceship, could play chess, and interact with humans as if it was a human itself. So the question is, what happened to the dream of the 1950s and 60s when everyone was predicting that humans would be obsolete by the 1970s?
Well, your observation is correct. I would say it wasn't everyone predicting that. There were some famous predictions from Simon and Newell at Carnegie Mellon, which came into disrepute. But there was over-optimism because machines were doing adult activities, like solving some unsolved theorems from Russell and Whitehead, and doing these adult activities, playing chess, in some narrow cases making medical diagnoses as well as doctors and so on. So it seemed it wouldn't be long before a computer could do everything. Another 10 years went by, and we realized that computers, while they were able to do these high-level analytic tasks, were not able to do some things that a 4-year-old can do, which is, let's say, tell the difference between a dog and a cat or recognize faces. And this is really a fundamental issue, in my view, that the fundamental basis of human intelligence is not analytic, logical thinking. And, in fact, machines can do that a lot better than humans in most cases. The fundamental basis of human intelligence is pattern recognition. We can see that in the contrast with how machines play chess, which is this minimax combinatorial expansion of move, counter moves, which it does largely through brute force. It can look at millions or even hundreds of millions of board positions in a second. Kasparov says he looks at less than one board position in a second, but humans use their tremendous powers of pattern recognition to recognize situations they've thought about before. And we don't think fast enough. Our interneuronal connections compute 200 calculations per second, which is about 10 to 100 million times slower than electronic circuits, but we have 100 trillion of them, all computing simultaneously, self-organizing. Information is really represented as a pattern. No key connection is all that important. It's a very different paradigm from computers we're used to, and it's a very good architecture for recognizing patterns in a profound way. That is really the heart of human intelligence. Now, we have been making steady progress in pattern recognition. I could give many examples of that, both in terms of recognizing language and speech, character recognition have all improved gradually. Even in chess, machines have become better qualitative players, so you have Deep Fritz and the current programs working actually as well as Deep Blue, despite the fact that they're about 100 times slower, that they're doing a better job of pattern recognition. So we are making steady progress on that, and that is really the key issue now. And part of the guidance we'll get in terms of creating the templates of human-level pattern recognition is to actually understand how humans do it, which brings up the issue of reverse engineering the human brain. It wasn't long ago before people were saying, well, you know, our intelligence is just below the level necessary to actually understand our own intelligence. But what we're finding is that as we're able to actually instrument the brain and see what's going on, and our ability to scan the human brain and to actually see the connections and the firings of interneuronal connections and synapses is increasing, actually doubling every year, we are able to develop very detailed mathematical models of neurons and neuron clusters. Lloyd Watts and his colleagues have actually created a reverse engineering of the whole acoustic area of the brain involving 12 different regions with a great deal of detail, have re-implemented that in software and submitted that to psychoacoustic tests, which performs very comparably to human auditory perception. If you follow all the exponential trends in computation, communication, brain scanning, exponentially growing knowledge of the human brain, it's, I think, conservative to say we will have reverse engineered the principles of operation of the human brain within a quarter century. And that will provide us, you know, more powerful biologically inspired methods for pattern recognition.
Okay, well, we've had several AI specialists on the radio show before, among them Rodney Brooks of MIT, the director of the Artificial Intelligence Laboratory. And I asked him a key question, and that is, well, how powerful are the MIT robots? And he was very proud to say that he's the godfather of the Mars rover, an advanced robot which actually wandered on the surface of Mars. But he was honest and said that his most advanced robots have the intelligence of a cockroach. In fact, cockroaches do it a lot better, he said. Cockroaches can scope out environments, see obstacles, boulders, maneuver around them, and they're quite good at this. And robots at Carnegie Mellon and Stanford, well, when they walk down the hall, it's lucky if they don't gouge out a piece of the wallpaper when they walk down the hallway. So how smart are our robots? Are robots really so dumb that they are really insect level at the present time, barely able to understand chairs, tables, the ceiling, the roof, people maneuvering around the room? How smart are the robots today?
Well, robots and artificial intelligence in general are operating far below biological levels, both in terms of hardware and software. And I think it's worthwhile talking about both of those, but also to understand that we're making exponential progress in both of these realms. And exponential progress really sneaks up on you. And just to use an analogy, Kasparov played the best machines in the 1990 at chess, and they were pathetic, and he scoffed at them. And it was just inconceivable that they would ever reach his level. But they gradually got better. They're doubling in performance every year, gaining 40 chess points every year, and chess scale is exponential. And then they surpassed him, operating at or beyond his level by 1997. We'll see the same thing in other areas. And it's easy to lose sight of tremendous power of exponential growth. We are doubling computation at least every year, and we'll talk a little bit later about the issue of Moore's Law, but I believe that this phenomenon will continue past Moore's Law into three-dimensional computing. And in terms of software, we're making exponential progress, as I mentioned, in understanding and reverse engineering the principles of operation of the human brain. There's a new brain scanning method now that's being developed, which will be available within a couple of years, that will actually be able to see individual nerve fibers firing in a cluster of thousands of neurons at very high resolution, very high resolution also in terms of time scale, which will really give us the means to reverse engineer those circuits. I mean, so far, we've been really unable to see what's going on. It's very hard to diagnose a circuit if you can't instrument it. But if you can put sensors on in the right place and see what's going on, it's very straightforward to reverse engineer. The human brain, of course, is created by a genome that doesn't have very much information in it. Even though the human brain itself appears to contain thousands of trillions of bytes, the genome only has about 12 million bytes of information to characterize the initial design of the brain, because there's a lot of random wiring in the way it's actually constructed, which then self-organizes to reflect its experience with the world. So the principles of operation are of a complexity that we can't understand. And that will provide us at least biologically inspired paradigms for the software of intelligence. And so the capabilities of all of these systems will improve quite steadily, and we will master different levels of biological intelligence. Ultimately, I believe within less than 3 decades, by 2029, these machines will be operating at human levels and will combine human levels of intelligence, the subtlety and suppleness of human pattern recognition, with some of the natural advantages of machines, most notable of which is the ability to instantly share knowledge.
Now let's talk a little bit about Moore's Law, the doubling time you mentioned of 18 months for computers, meaning that at Christmas time, your computers are almost twice as powerful as they were the previous Christmas. Exponential growth in bacteria, for example, eventually seals off, otherwise bacteria would take over the entire planet Earth. And exponential factors do taper off because of external effects. Now, with Moore's Law and computers, the engine driving Moore's Law is ultraviolet etching technology, by which we can etch tinier and tinier transistors on a silicon wafer the size of your thumb. But eventually the transistors get so tiny, you hit the quantum theory. And at that point, you get short circuits. Leakage takes place. All hell breaks loose. And by 2020, all bets are off. The Intel, one of the senior engineers at Intel, admitted recently in a major paper that, yes, they can see the end of the tunnel. And that is, at a certain point, it's going to be prohibitively difficult to etch silicon components that are tinier and tinier, and eventually you get leakage because you don't know where the electrons are. Some people have said, let's make three-dimensional cubes. But the problem there is you have heat generation, enormous quantities of heat generated in three-dimensional cubes. So the question is, what happens after 2020 when all hell breaks loose and Silicon Valley becomes a Rust Belt?
Well, it's a key question, and to examine that, I've done a number of things. I have been an ardent student of technology trends. I've been measuring the actual power of different technologies for 25 years. I have a team of people doing that. One thing I did is put 49 famous computers over the last century, long before there was a Moore's Law, on an exponential chart. And this exponential growth has been going on not just for Moore's Law, but back through 5 different paradigms. Moore's Law, the shrinking of transistors on a flat integrated circuit, was not the first, but the 5th paradigm to provide exponential growth to computing. And every time one paradigm ran out of steam, because as you correctly point out, every method of exponential growth eventually runs out of capacity. Rabbits in Australia eat up the vegetation and stop growing exponentially. They even reverse direction. Every time that happened, another paradigm came along and started another S-curve of exponential growth. They were shrinking vacuum tubes to continue exponential growth. Finally, they couldn't shrink them anymore and keep the vacuum. That paradigm ended. Transistors came along. And the next paradigm will be three-dimensional computing. We live in a three-dimensional world. Our brain's organized in 3 dimensions. Our brain, by the way, uses a very cumbersome, very slow electrochemical information processing method. That's 200 calculations per second. They're digitally controlled analog transactions, but they're roughly comparable to calculations. At least 10 million times slower than electronic circuits, but it gets its tremendous power from the fact that it's organized in 3 dimensions. Now, the brain itself is an existence proof of the feasibility of organizing circuits in 3 dimensions and dealing with the heat problem I proposed three-dimensional computing at the sixth paradigm to replace Moore's Law, which was the fifth paradigm in my book, The Age of Spiritual Machines, 4 years ago. It was considered a radical notion then. I would say it's much more of a mainstream expectation at this time. There's been tremendous progress in building working three-dimensional circuits over the last 4 years. There's been a steady flow of breakthroughs, including conceptual examinations of this thermal issue that you alluded to. And there are ways of designing the circuits in porous ways to deal with the heat issue. 1 watt of power, which would not generate that much heat, would be sufficient to emulate human brain capacity in a cube that would be very tiny. So the thermal issue is, in fact, a key challenge, but there's a lot of confidence that that's feasible. And we still have at least a dozen years to go. And what we've seen typically is when the end is in sight for a particular paradigm, it creates tremendous pressure in the R&D community to create the next paradigm. And we have a lot of advance warning this time. And already, in fact, just using conventional lithography and going into the third dimension, because after all, even conventional circuits have 14 or 15 layers of material, so they do have some three-dimensional capacity. And there's been successful efforts to build circuits with dozens and even up to 100 layers of circuitry just using conventional techniques. There are many different approaches. The most effective appears to be carbon nanotubes, which is what I had predicted in my book 4 years ago.
Okay, well, the heat problem, as you mentioned, is quite fierce. Engineers tell me that very soon, even cubicle computers will generate so much heat you can fry an egg on them. Let me ask you a question about the the top-down approach and the bottom-up approach. When we had Rodney Brooks on the radio, he said that there are two approaches to artificial intelligence, top-down and bottom-up. The top-down approach has dominated AI research for the last several decades, and the goal there is to have a CD-ROM with all the laws of common sense, all the laws of logic on it. You simply put the CD-ROM in a computer, and all of a sudden your computer says, I think, I am aware, I am conscious, okay, I am alive. That's the top-down approach, which failed rather miserably. We know that there are hundreds of millions of lines of common sense. We can't put them on a CD-ROM. There's so many of them. The other one is the bottom-up approach, which follows nature, Mother Nature, allowing machines to learn like bugs, like infants, to bump into the environment. And that approach is like a neural network approach. So could you explain to us a little bit about neural network theory? And this, of course, means that our brain, in some sense, is not really a digital computer at all. That perhaps we were sort of misled over the last 50 years in terms of the successes of silicon, but the brain is really a neural network and not really a Turing machine at all. Could you elaborate?
Well, I've always been a strong advocate of what you're referring to as the bottom-up approach. As I mentioned earlier, the brain, the design of it, characterized by only about 12 million bytes of compressed information in the genome. You might wonder, how could that be when the brain itself contains millions of times more information than that? And the way it works is the genome specifies a particular design, but in a particular region, the actual wiring of the connection is random within certain constraints. And we know that that's the case, having watched how that process unfolds. Then there's actually kind of an evolutionary process where the connections that make the most sense in the environment survive. And it's actually twice as many connections in the newborn baby's brain as exists a year later. There's a lot of self-organization. And the brain has the capacity to interact with its environment, make sense of the environment, as well as make sense of its own design and its own interconnections actually continually being repruned and reconnected to make sense of the environment and to learn. And that is really the only approach that's going to work. I think the Psych project, Doug Lynat, is interesting. It's accomplished a lot, but I never felt that we could build human-level intelligence that way. We really have to build it the way nature builds it, which is a machine that has the capacity to learn, and then provide for its education. Now, neural nets is sort of one attempt based on a crude model of how human neurons work. which actually builds lots of neuron simulators and connects them somewhat the way the brain connects them and lets them self-organize. And there's a number of different approaches to neural nets. They're all very simplified from what we now know is true of actual neurons. And as progress in reverse engineering the human brain progresses and we have more sophisticated and realistic models of actual neurons, we can build more realistic biologically inspired paradigms. But in general, pattern recognition, which is my field, works by emulating nature in these self-organizing methods. We set up some approach, which could be a neural net. There's things called Markov models, which is the mathematical cousin of neural nets. There are evolutionary algorithms that actually emulate evolution. And actually part of human learning has a kind of an evolutionary process take place inside the brain for the better connections that survive. And we use these techniques in our pattern recognition approach. We'll actually simulate evolution, have different solutions to a problem, compete with each other through thousands of generations of simulated evolution. And these biologically inspired methods are very powerful. They give results that are essentially unpredictable, just as sort of human decision-making is unpredictable without actually letting it unfold. And this is really the approach that will work, trying to define as analytic, logical rules every bit of common sense. It's not going to work. It's too complex, too unwieldy, and it's not how human intelligence works.
Well, I'm afraid that's it for Exploration. Once again, our special guest today was Ray Kurzweil, author of the book The Singularity is Near.